Hello everyone. My name is Asim Abbas. I am doing PhD from University of Birmingham in computer science. So today I will present harnessing open source LLMs for tender name entity recognition. So these are the co-author of this research article. First, I want to give the abstract idea about the research article. So we are using two open source. We are using two data set. One is open source dataset from the Singapore procurement, and other is the closed source commercially sensitive dataset which is provided by the Siemens. So we are performing tender name entity recognition task using five different open source large language model in different learning environment. As a result, we have achieved 85% plus F1 score on open source dataset and 90 plus F1 score on closed source dataset. So I want to introduce what is NER in tender domain and what is tender domain itself. So NER is a cornerstone task in natural language processing for identifying and classifying entities from unstructured text like names, person, organization, etc. So these entities further used for information retrieval, text summarization, and chatbots. So what is tender domain? So tender is a formal request for proposal or offers issued by companies or government agencies. So these documents consist of often 100 pages or more than 100 pages. While extracting these entities manually from these documents is time consuming, labor intensive, and error prone. So if we see this example, this is a tender text. This text included tender number, supplier, award date, tender status, tender date, and the amount that is issued for the tender. However, extracting these entities, we have some key challenges. Like tender document are highly sensitive and very confidential. It is not available. It is not freely available in the public. Similarly, every organization have different tender terminologies and structures. So these are the problem that we have identified. So traditional NER approaches for tender document face significant challenges like they require extensive annotated data, struggle with domain-specific terminology, and raise privacy concern. Similarly, commercial LLMs like GPT-3 or nowadays we have GPT-5 uh, are effective to use but involve high cost and potential data privacy risk when processing the sensitive tender information. So this is the research contribution that we have made. So our research make three key contributions. We are the first to evaluate open source LLMs for tender and your task. Similarly, we conducted a comparative analysis across different learning environment or evaluated both open source and closed source data set, and we demonstrate feasibility on computer grade hardware addressing cost and privacy concern. So this is the methodology overview. As I said previously, we employed in context learning strategy for tender entity extraction across three environment: zero shot, one shot, and few shot. So the advantages of ICL approach over traditional approach, we do not need domain-specific annotated data to train the model. Similarly, we do not need huge resources because currently we have framework. We can use LLM with our existing resources. Similarly, using LLMs or in context learning environment give better generalization across different data set. Notably, we can run and deploy all these experiment on standard desktop with just 16 GB RAM and AMD Ryzen 5 CPU using the OLAMA framework. which is proving that expensive hardware isn't necessary. So in this study, we have used five different open source models, all with under 8 billion parameters. So our selection criteria focus on recent release after July 2023, popularity and community recognition, reasoning capability, and high ranking on Hugging Face and Olama leaderboard to ensure a balance of capability and efficiency. Similarly, we have run or experiment this model in three different environments: zero shot, one shot, few shot. And this is the generic concept. I hope everyone know about this, but I want to show you the prompt. So this is the prompt that we have designed. This is a prompt template for one shot learning, but we have also the prompt. You can go to the paper. There we have given the link of the prompt that we have to actually used in our paper in three different environment, which is available on the GitHub. So these are the data set that we have used. One is the Singapore procurement dataset, which is open source, available on the Kaggle, and other is the Siemens dataset, which is highly confidential and we cannot open source this data. So there are 23,909 instances in this dataset, and there are seven different entities in open source data. Similarly, in the Siemens dataset, consists of 30 documents, and there are nine entities that we are focusing to extract. These are the evaluation matrices that we have utilized for computing model performance, like precision, recall, and F1 score. Similarly, here we are not applying strict matching criteria for identifying the entities, but we are applying the soft matching criteria for entity identification. So these are the results that we have achieved on the open source data set while utilizing five different LLMs. So as a result, the Llama achieved 91% F1 score in zero shot environment, and while Falcon 3 achieved 86% F1 score in one shot and 98% in few shot learning. Overall, all these models consistently struggle with extracting mean category and tender description entities due to their complex embedded structure. Similarly, these are the results that we have achieved on a closed source data set. As a result, Pi 3 achieved almost 97% of one score in zero shot, and Llama 3 achieved 98% in one shot environment, and Mistral and Folker achieved same similar F1 score of 99% in few shot learning. Uh, these entities, these entities were available in the form of table, which is highly complex. While extracting the text from these entities using existing text extraction tool, the structure of the text is lost during extraction, uh, which presented additional challenges. However, all open source model maintain strong performance above 95% F1 score. So we have also performed comparative analysis of open source and closed source LLM. So in the closed source, we are using ChatGPT 4 or GPT-4. So the while GPT-4 outperform all open source model on both dataset, while achieving 99% F1 score on open source and 100% on closed source dataset in few short learning. But but our open source models still deliver impressive result above 85% and 90% F1 score respectively. Likewise, these results demonstrate that open source alternative can provide viable privacy preserving solution for sensitive domain like tender processing. To conclude our presentation and give the future plan, our study demonstrates that open source LLM can effectively perform tender annual with impressive result on consumer hardwares while maintaining privacy and cost. So in future, we plan to fine-tune a smaller model like BERT on open source standard data and extend this research to other data limited domains like healthcare or clinical domain and explore advanced prompt engineering technique to maximize the performance without extensive training or fine tuning. So finally, I want to acknowledge the Simon for supplying tender data set used in this study. Similarly, this research was supported by the University of Birmingham on 25th University Research Fund. So I gratefully acknowledge their fund contribution. If you have any question, you can query on my email. Thank you.